Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Channapkot. Dear students, in the previous class we solved some numericals which are related to conduction, heat transfer. With help of Fourier's law of conduction, what we done? We calculated the rate of heat transfer and temperature gradient. Dear students, come today we will learn some activities of conduction, heat transfer. So live examples, live applications I will take, and I will try to explain you what is conduction heat transfer. So dear students, conduction heat transfer activities. So first activity, what I will do, dear students, I will take a burner, okay, that is my heat source. Then I will take a metal spoon, and in that metal spoon I have taken small quantity of oil. Then what I will do, with help of this burner I am going to heat the oil through a metal spoon. Then what happens here, it is the become high temperature region, or else I can call it as a hot end. Metal spoon, it is nothing but what? Hot end. When it comes to metal spoon at this side I can call it as a cold end, dear students. So now what is going to happen here? Now leave it for a while, or sometimes what happens, the heat is going to absorb, heat is going to supply to the spoon at this hot end. Then what happens, the heat is going to transfer from hot end to cold end through a metal spoon. That type of heat transfer we are going to call it as a conduction heat transfer. Then that rate of heat transfer in that material is represented with a notation that is Q. Then the amount of heat transfer which is going to take place in metal spoon is represented by with a notation, that notation we can call it as a Q. That is what conduction heat transfer, dear students. One example. Whatever the heat is going to transfer from hot end to cold end, right, through metal spoon, that type of heat transfer we are going to call it as a conduction heat transfer. Why so? In the metal spoon, the particles or atoms are close to each other and they will not alter their position. They are going to transfer heat from one part of the system to the another part of the system, or one end to the other end, or hot end to the cold end. Where the molecules are at under rest, they are going to transfer heat. That type of heat transfer is called as a conduction heat transfer. This is one our day-to-day live examples. And one you can see here now, I have written Q here now. Then how much amount of heat is transferred in that metal spoon? That I can calculate with help of an equation. What is that equation? That is Q is equal to minus K into dt by dx. This is the equation which is given by the great scientist Fourier. This is one activity we can see in our day-to-day life, dear students. Okay, fine. Now I will move towards next example. I will take in a hot coffee. Then I will put a metal spoon into the hot coffee. Let us say the temperature of hot coffee is 80 degrees Celsius, dear students. Okay, then this end, the temperature here I will mark here now, this is 0.1, okay, and here it is I will mark as a 0.2. At this point I will call it as a temperature T1, and at this point temperature I will call it as a T2. Now we can see, dear students, when you inserted or dipped a metal spoon into the coffee, right, the coffee having temperature of 80 degrees Celsius. Hence what happens, the heat is going to transfer from 0.1 to 0.2. The temperature at 0.1 I can mark here as a T1. The heat is going to transfer here, right? The heat is going to transfer through a metal spoon. That type of heat transfer we are going to call as a conduction heat transfer. Then conduction heat transfer notation I can give here as a Q. Then the amount of heat transfer through that metal spoon, that too from hot coffee to surrounding. Hot coffee to surrounding means what? Ambient. The temperature will be 30 degrees Celsius. That means what? Heat is going to transfer from 80 degrees Celsius to 30 degrees Celsius through a metal spoon. That type of heat transfer you can call as a conduction heat transfer, and that conduction heat transfer is represented by notation that is Q. Then the rate of amount of heat transfer, or rate of heat transfer or amount of heat transfer for unit time, I can calculate with the help of an equation. That equation, that is Q is equal to minus K into dt by dx, dear students. Where K is nothing but what here now? Thermal conductivity of the material. Then A is the area of the metal spoon. Then dt is the change in temperature, that is 80 degrees Celsius minus 30 degrees Celsius we can take. Then dx is nothing but what? Thickness of the metal spoon. So this is one example we can see in our day-to-day life. Okay, that is best example for what? Conduction heat transfer. Okay, second activities. So now, dear students, when the heat is going to transfer, right, that when the heat is, I told heat is going to transfer here also from metal spoon, from hot end to cold end through metal spoon. One thing here also you can take, when it is a coffee, right, heat is going to transfer from 1.1 to 0.2, or else high temperature region to low temperature region. When the heat is transferring, right, there are some factors they are going to affect on the heat transfer. There are some factors they are going to affect on the heat transfer. So heat transfer rate, what is heat transfer rate? That is joules per second, I can say, or I can say it as a watt. Okay, rate of heat transfer I can measure in terms of joules per second or watt. Okay, fine, dear students. Then first factor which is going to affect on the heat transfer or rate of heat transfer, that is first factor. What is first factor? That you can see here. 1 minute. Okay, first factor, copy temperature. If I have taken, right, copy temperature, dear students, you can see here now. 1 minute. Okay, I will take a copy cup, right? If the temperature of copy, if it is 60, then rate of heat transfer is different. If it is 70, the rate of heat transfer is different. If it is 80, the rate of temperature is going to differ. So that means what? If the more copy temperature, if the temperature of copy is more, then rate of heat transfer is going to more. That means what? If more copy temperature, then what we can say, there will be more amount of heat transfer, dear students. If the more temperature of coffee, more amount of heat transfer. That is one of the important factors which is going to affect on the rate of heat transfer, dear students. That is what? Q is equal to. Okay, fine. Next, spoon material. That is also very important, dear students. Whatever your spoon material you have taken, right, that also play a very important role. Either you are taking metal or non-metal, that's also important. If it is a metal, again in the metal, whatever material you are taking, what type of spoon you are taking, whether it is copper or aluminum or steel or anything. So that's also affect the rate of heat transfer. If you are taking non-metal, like plastic or wood, that means what? Heat transfer is going to differ. That means the type of material also important while transferring the heat transfer. That's also it is going to affect on the rate of heat transfer. Material, either it may be metal or non-metal, dear students, non-metal. Okay, that is one. Then next important factor here, copy, you can take it here now. The length of the length of the spoon also play a very important role. If more length, then rate of heat transfer will be less. Why so? Because temperature gradient will be less. If the length of the spoon is less, then what will happen? The rate of heat transfer is more actually. So why so? Because there is if the length is short, then what we can say, there is shorter spoons have steeper temperature gradient. Hence what we can do, we can accelerate the heat transfer. Hence the length of the spoon also play a very important role in the heat transfer. If more length, less heat transfer. If the spoon length is less, then we can transfer more heat. That is what? Spoon length of the spoon, dear students. Next, spoon thickness. That thickness also play a very important role. Why so? Through that thickness, heat is going to transfer. If more thickness, less heat transfer. So that means the spoon thickness also play a very important role, dear students. If thickness of the spoon is more, less heat transfer. If thickness is less, what will happen? Rate of heat transfer will be more. Hence, thickness of spoon also play a very important role in the conduction heat transfer. Then ambient temperature, dear students, ambient temperature. If ambient temperature, I have taken copy temperature 60, 70, 80 degrees Celsius, like that ambient temperature, if it is 20, if it is 25 degrees Celsius, if it is 30 degrees Celsius, that's also playing a very important role in the rate of heat transfer. If the ambient temperature is very less, that means what? There is a more change in temperature. That means what? If it is, assume that, dear students, I will take higher temperature 80 degrees Celsius, then ambient temperature I will take 20 degrees Celsius. The change in temperature is to 80 minus 20. That means what? The delta T is equal to 60 degrees Celsius. If the delta T is more, then rate of heat transfer is going to increase, right? So you can see the amount of heat transfer we can calculate with help of conduction heat transfer equation, right? That is Fourier's equation. That is Q is equal to minus K into dt by dx. dt is in the numerator. If the change in temperature, if it is more, then rate of heat transfer is going to more. If thickness of the plate is more, then it is in the denominator. That means what? That there is a decrease in the heat transfer, dear students. Hence So copy temperature, spoon material, spoon length, spoon thickness and ambient temperatures play in a very important role while transferring the heat from hot copy to the ambient air, dear students. This is one example we can consider and we can understand what are the factors they are there in the conduction heat transfer. Like that you can take in our home when your mother is cooking something else, right? They are putting spoon into the hot water, right? After some times or while they can feel heat at this end. That means what? Heat is transferred in a metal spoon through conduction. That conduction heat transfer we can calculate how much amount of heat is transferred. That I can calculate with help of this equation. That's fine. Now one more activity we can see, dear students. I will take two spoons here now. One spoon hot spoon, another one cold spoon. I will contact each other. I will bring these two spoons near to each other. I will contact them. Then what happens? I will give it sometimes or after sometimes what happens, the heat is going to transfer from hot spoon to cold spoon. When you brought these two spoons near to each other, right, and you were contacted, then what happens? After some times heat is going to transfer from hot spoon to cold spoon. That heat transfer is represented as a Q. That means what? When you contacted each other, because of that physical contact, heat is going to transfer from one hot spoon to cold spoon. That type of heat transfer we can call as a conduction heat transfer. Then that conduction heat transfer we can represent here as a Q here, dear students. Hence what we can say, heat is transferred from hot spoon to cold spoon. After some times this cold spoon become warm spoon. How it's so? Why it's so? Because the heat is transferred from hot spoon to cold spoon. Hence the cold spoon become hotter. And after sometimes what happens? Both spoon become equal in temperature. If the heat is transferred in that fashion, that type of heat transfer we are going to call as a conduction heat transfer. Again, conduction heat transfer can be calculated with the help of a Fourier's law of conduction equation. Okay, fine. Now third activity, dear students. That what is third activity? So I will take an aluminum rod. Okay, I will take an aluminum rod, and what I will do, I will on the surface of the aluminum rod I will put some iron nails held with the wax. I will take a wax. In that wax I will put a nails. Then that nails I am going to attach onto the aluminum rod. Then what I will do, dear students, I will heat the aluminum rod with the help of a heat source, that is lamp here now. Then what happens? Heat will start to move from high temperature region, that I will mark here as a 1. Then it will try to move towards the low temperature region, all cold region. So heat is moving in this direction. When the heat is moving in this direction, right, that heat is nothing but what? Conduction. Why it's so? Because it is happening in the aluminum rod. What is conduction heat transfer? That I have explained in detail in the previous videos. If you want detailed explanation, you can go back and you can study what is conduction heat transfer. Okay. Now what happens? Heat is going to transfer, conduction heat is going to transfer from high temperature region. Once the heat reaches the particular point, right, then what happens? The iron nails is going to fall down. Why it's so? What we can see? That we can see that we can tell that the heat is transferred from this point to this point. Because of the heat, the wax melted. Hence what happens? The nail is going to fall down. So similarly, now this point is over. Now what will happen? Again, keep on add the heat. The heat will move from again this point to this point, and it is going to reach this point. Once the heat is transferred to this particular point, right, again this nail, whatever it is held with wax, right, it is going to fall down. Then what we can experience there, what we can observe there, the heat is transferred to this particular point. Because of that heat supplied, because of that heat transfer, the nail fall down. That heat transfer is happening right from this point to this point. That heat transfer we can call as conduction heat transfer. Then that conduction heat transfer we can calculate with the help of what? That means what? How much amount of heat is getting transferred through that aluminum rod. That I can calculate with the help of an equation, that is minus k into dt by dx ds student. Okay, this is one activity we can do. Then one more activity, fourth activity, dear students, you can see here now in your home, right, when cooking, right, you can observe you put in a metal spoon. Then what will happen? And leave it for 2 minutes or 5 minutes. And one thing, I will take two spoons here now. One is metal spoon, another one is plastic or wooden spoon. Leave it for 4 or 5 minutes. Okay, hot water is there. You are supplying heat continuously. The water is getting boiled. So then what happens? You can feel, right, that heat is going to transfer from hot water to hot water from one end to another end through metal spoon. You can observe, you can feel, you can try to hold the metal spoon at this particular point. What you can do, what you can experience, you can experience some amount of heat. That why it's so, because heat is transferred from hot water to end of the cold spoon. That means what, that conduction heat transfer is taking place in a metal spoon. Okay, but when we are going to hold the plastic or wooden spoon, right, you will not feel the heat. Why so? Because heat is not at all transferring from high temperature region to low temperature region, or hot region to cold region. Why so? Because the plastics or woodens or the non-metals, they are the bad conductors of heat, or bad thermal conductors, we can say. When we are putting, right, for 2 or 3 minutes, after immediately sometimes immediately what we can do, what we can experience, we are going to experience the heat. That means what, that heat in the metal spoon. Why so? Because metal spoons are the best thermal conductors, hence heat is transferred in the metal spoon. What we can say, dear students, metal spoons are the good thermal conductors, and plastics or foods or non-metals, we can say they are the bad thermal conductors. Okay, here metal spoon is good conductors and plastic or wooden is the poor conductors of heat. Hence we can't feel heat in the wooden or plastic spoon, dear students. These are some activities which are related to conduction heat transfer, day-to-day activities. To understand that conduction heat transfer, I have taken, dear students. If you really like my videos, please do subscribe, like and comment and share to your friends, and please, I request you, please support. Thank you.